Good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. And in this video, we are going to answer the product rule, question 2C, which reads y is equal to square root of x multiplied by x minus x squared raised to the power 2. And as we can see, if we remember from the other videos, they were saying find dy dx using the product rule. So you have been restricted to use the product rule. So to answer this question, we are going to use the product rule. Okay, so to continue, what will we say? We'll say solutions, right? So simply say solutions. Then we'll say, we'll write down what we have. Y is equal to root x, okay? Y is equal to root x multiplied by x minus x squared raised to the power 2, if I'm not mistaken. Okay, so we're going to let one function be equal to u and then the other function be equal to v. Okay, I was just saving the document, sorry for that. So we'll say let u be equal to root of x, and then we'll say v be equal to x minus x squared raised to the power 2. Okay, so we're going to differentiate these functions individually. So we're going to say du dx, or first of all, if I were to differentiate this in my head, it would look very confusing. So let us try to write it like this. So u is the same as what? Is equal to x the power half. And then we'll just write v once more, which is equal to x minus x squared raised to the power 2. The square root has an invisible 2, okay, which we do not write. But the cube root would have written a 3 here, a 3 there. I hope you can see that what I've done. So a 3 right there would have indicated, if it was a fourth root, with a 4 there. Fifth root, a 5 there. So what? But for the square root, we don't indicate it, okay? So we are going to say du dx is equal to 1 over 2 x to the power negative half. If you don't know how to differentiate this, I have a playlist on how to differentiate. Then dv dx is going to be equal to 2 multiplied by what? X minus x squared. So we maintain the bracket, then to be raised to the power 1 now, then times derivative of the whole, in this particular case is derivative of x is 1, then derivative of x squared is going to be 2x, so 1 minus 2x, like that. That's what we are going to have. So that's what we are going to have, just like that. So simplifying it, we can write it like this. As we can see, there's a negative power for x here, here. So we can make it become positive by taking the x down, okay? Du x would be equal to 1. Let me just clear that up. I want to create more space. Du x would be equal to 1 divided by what? So to divide by a 2x to the power positive half, like that. And then you're going to have dv dx. dv dx is going to be equal to what? A 2 multiplied by x minus x squared multiplied by what? 1 minus 2x. That's your dv dx, as you can see up there. And then your du dx can still be, so let's underline, this is our dv dx, but if your du dx can still be simplified, right? So you can say du dx is equal to 1 divided by 2. X to the power half is the same as square root of x. We already explained that in the beginning of the video. So this is your du dx, like that. So like that. Let me move that dash. So that's your du dx. And then what we are going to say, we're going to write the formula for the product rule. The formula is dy dx is equal to u dv dx plus a v du dx is equal to, we have a u multiplied by dv dx. Our u was what? Our u, if we go back, was x to the power half, which is the same as square root of x. So we have square root of x, then our dv dx was that, what we have there. So what we have there is 2, okay, let me write this in a square bracket. So it's a 2 multiplied by x minus x squared multiplied by 1. So multiplied by what? 1. Let me write that like this, 1 minus 2x. We can close the square bracket. Then plus a v. Our v in this case was what? It was x minus x squared raised to the power 2. And then du dx was a 1 divided by 2 root x. So I'm going to write it down due to space. I'm going to say v, which is plus, let me write it down here, x, okay, so it's x minus x squared raised to the power 2 multiplied by what? 1 over 2 square root of x. That's what we have. So what we can do is we can just simplify 1 or 2 things, but we are almost done. We just simplify 1 or 2 things. We'll say is equal to, we multiply square root of x with 2, we're going to have 2 root x. Okay, so 2 root x, like that. And then we maintain everything else. So it's going to be multiplied by what? Multiplied by x minus x squared raised to the power 2. Oh no, this one's not raised to the power 2. Yeah, multiplied by 1 minus 2x. Then plus x minus x squared, right? Multiplied by a 1 over 2 root x, like that. Then to continue, what do? We can see that x minus x squared is common. So because it's common, we are going to simply factor it out. Then we'll say therefore dy dx is, so dy dx is equal to what? 2 root x. Sorry, let's factor out what's common. So dy dx would be equal to, we have x minus x squared in a bracket. Then what to remain with is what? 2 root x. So going to remain with 2 root x. And then if we look very closely here, we have x minus x squared. Here is supposed to be a power 2. Okay? So it means we're going to remain with what? We're going to say plus x minus x squared. is going to be raised to power 1 multiplied by whatever remained, which was a 1, okay? A 1 divided by 2 root x, like that. So that's what we have. And that would be our final answer. So we can leave it in the form of square brackets. It's quite alright. So we can do that. So we have x minus x squared, then 2 root x, x minus x squared multiplied by 2 root x. I hope you can see that, multiplied by 2 root x. This would be your final answer. So if you see, these questions maybe might be tricky, but the exam questions will be very hard. Okay, I mean very simple. Sorry, what am I saying? They will be very simple. Don't worry. As we start practicing the exam questions, we'll find that they are very simple as compared to the questions that we are answering now. Thank you so much for watching. This has been Cornelius Tubinda with another video, and